We're going to go ahead and get started on the Unit 3 review. We're just going to work through the problems here. Hopefully you've got most of them done already. So if you got them done, just check your work, see where any possible hangups might be before your quiz tomorrow. So question number 1 and 2, we're asked to identify or find any vertical, horizontal, or oblique asymptotes, if any, of this rational function. Excuse me. So first thing we're going to do is find the vertical. In order to find vertical asymptotes, we're going to take the denominator and we're going to set it equal to 0. So we're going to have x squared plus 3x minus 4 equals 0. Then we're going to take this equation that we just created and we're going to solve for x. Since this is a quadratic, I'm going to go ahead and factor it. So I'm going to use the asterisk method. Using the asterisk method, I'm looking for two numbers that multiply to give us -4, but add to give us +3. So that's going to be +4 and -1. So I'm going to have factors x plus 4 and x minus 1. Then we're going to take our two factors and set them equal to 0. So that's going to give us our two vertical asymptotes, x equals -4 and x equals 1. I'm going to label them VA to identify that those are my vertical equations. The next on the list, it asks us to identify horizontal. In order to find the horizontal asymptotes, we're going to compare the degrees of the numerator and the denominator. So I'm looking at these two terms here. The highest degree of the top is 2. The highest degree of the denominator, the bottom down there, is also 2. So since the degrees are equal, we're going to make an equation with the leading coefficients. So in this case, our horizontal is going to be y equals, and then the fraction made with the leading coefficients, in this case 2/1, which is just y equals 2. And that's our horizontal. In this case, we'll never have any oblique asymptotes. Those occur when the denominator is 1 less than the degree of the numerator. We're not going to go into that for this course because we don't have enough time. So we're just worried about horizontal and vertical. The instructions on the final will have oblique in them, but it will not involve an oblique asymptote. So we're going to do the exact same process on question number 2. We're going to start off by setting the denominator equal to 0. Then we're going to factor. And make sure when you factor, if you're using the asterisk method, that you put 6 in the top middle because you've got to multiply 2 times 3. So two numbers that multiply to give us 6, but add to give us 7, going to be 6 and 1. The 2 and the 6 are going to reduce, so we're going to have x plus 3 and 2x plus 1. I'm going to take both of these factors and I'm going to set them equal to 0. So x plus 3 equals 0 and 2x plus 1 equals 0. Solve both of these for x. X equals -3. And for the other one over there, I'm getting x equals -1/2. Again, I'm going to label those vertical, making sure I get both of them circled in my answer. They are both vertical asymptotes. Next up is the horizontal. In order to find your horizontal, you're going to compare the degrees in the numerator and the denominator. In this case, they both happen to be the same. Since they're the same degree, you're going to make a fraction with the leading coefficients. So we're going to have y equals 2/2, which would just be y equals 1. So our horizontal y equals 1. And we're always using x and y for these because it's representing the x and the y axis on the coordinate plane. X equals any number just gives you a vertical line, and y equals any number gives you that horizontal line. So always using x equals and y equals. It's not appropriate or customary to say that your vertical asymptotes are -3 and -1/2. It's always going to be x equals -3 and x equals -1/2. So that's the quick review from day 11, I believe. These aren't really in the order that we did them in class, but they're all things we covered in this unit. Questions 3, 4, and 5, we're going to solve these rational equations. When we solve these rational equations, we always want to remember to check for extraneous solutions anytime we get more than one answer. So for this first question here, question number 3, we're going to look at all the denominators and decide what the least common denominator is. So comparing these three denominators, I have 5p squared, 5p squared, and then just p squared. Well, the only thing that's missing from my least common denominator, if I write the first one, 5p squared is exactly the same thing as this. The p squared's in here, so everything is taken care of if I just write that first denominator. It doesn't happen very often, but everything in the denominators are accounted for in 5p squared. So now that I have this least common denominator, I'm going to multiply every single term by 5p squared. So now when I look at each one of these fractions individually, something out of that least common denominator should cancel with the denominator of every single fraction. So in the first fraction, the entire 5p squared is going to cancel with the entire 5p squared in the denominator. That's going to leave us with 3. For the second fraction, the 5p squared in the numerator and the 5p squared in the denominator are going to cancel each other out, leaving us with P minus 4. For the last term over on the right-hand side, this time the 5p squared won't cancel out completely, but I can, however, cancel out the p squared with the p squared. So that's going to leave us with 1 times 5, or 5 on the right side of your equal sign. Now, when I look at this, the first thing I notice is that this is a linear equation. P is not being squared. So I just need to combine like terms. I would combine these two first. P minus 1 equals 5. I would add 5 to both sides to get P equals 6. Question number 4. So for question number 4, make sure that you have 10 on top. I think I had the old version up there originally with a 1 on top, so change that to a 10. If you leave it as a 1, it's not going to be factorable and you get into a mess at the end. So first thing we're going to do is look at our denominators. I see a quadratic, so I'm going to go ahead and factor this right here. So when I factor that quadratic that's in the denominator, I'm going to get factors x minus 4 and x minus 2. So now when I look at my least common denominator, I see a set of parentheses x minus 4. I see a set of parentheses x minus 2. Those actually happen to match the other two denominators. So my least common denominator is going to be the x minus 2 and the x minus 4. So now we're going to go through and we're going to multiply every single term by the least common denominator. So we're going to multiply by x minus 4, x minus 2. And we're going to do that again all the way across. So now when I go to look at the first term there, you'll see that the x minus 4 will cancel with the x minus 4. The x minus 2 will cancel with the x minus 2. And that's just going to leave you with 10. For the second term, or the term right after your equal sign, the x minus 2s are going to cancel. And that's actually going to leave us with x minus 1 times x minus 4. This right here automatically screams to me that's a box problem. So in a minute, we're going to know to box that. For the last term, I want to point out there's a minus sign right here. I would never suggest leaving that there. I would make it a positive and distribute that negative to everything on the top of the fraction before I start canceling things out. And then I'm going to cancel out the x minus 4 with the x minus 4. And that is going to leave me with -1 times x and -1 times -2. Well, -1 times x is -1x, and -1 times -2 is +2. So now I'm going to take a moment and I'm going to box the x minus 1 times the x minus 4. So when I create my box, again, I'm going to multiply the x minus 4 times the x plus 1. Filling out my box, x times x is x squared. X times 1 is 1x. X times -4 is -4x. And 1 times -4 is -4. So when I combine like terms here on my diagonal, I'm going to get x squared minus 3x minus 4. This information right here is going to go up here where we have the x minus 1 times the x plus 1 times the x minus 4. So the 10 is going to get brought down, then we're going to have the x squared minus 3x minus 4 minus x plus 2. Now, when I look at this equation that we have left here, first thing that stands out to me is this x squared. Anytime we have x squared, we know we have a quadratic. Since we have a quadratic, I can think to myself, hey, since it's a quadratic, I need to move everything to one side in order to factor. So in order for me to factor this, I'm going to need to move everything to one side. I also need to combine some like terms. So first thing I'm going to do is combine like terms on the right-hand side. X squared gets brought down. These x's get put together to be -4x. The constants here, -4 and +2 combined to give you -2. And now I would move that 10 over by subtracting 10 from both sides. So 0 equals x squared minus 4x minus 12. Now that I've gotten this far, I want to go ahead and factor using the asterisk again. So filling out that asterisk, I have 1 in the top left, top right, -4 in the bottom middle, and 2 numbers that are going to multiply to give -12, add to give -4, going to be -6 and +2. So that's going to give me factors x minus 6 times x plus 2. Set them both equal to 0. That is going to give me 2 answers, x equals 6 and x equals -2. Remember that we were given 2 answers here. Since we ended up with 2 answers, we need to take those 2 answers and we need to check them to make sure that neither one of them is extraneous. So we need to check them in the x minus 2 and the x minus 4. If I plug in -2 here and here, neither one of these is going to give me 0. -2 minus 2 is -4. -2 minus 4 is -6. So the -2 works. Then I'm going to check +6. If I take +6 and I plug them in again, both places, 6 minus 2 is 4, 6 minus 4 is 2. Neither one of those is 0. So in this case, we have two answers, x equals 6, x equals -2. So now we're going to jump to question number 5. Looking at question number 5, the first thing we need to do is factor this denominator. So if you use your asterisk and you factor that, you're going to get factors x plus 3, x plus 2. Order does not matter as long as you have both of those there. And then we're going to multiply every single term by the least common denominator. Well, looking at the least common denominator, it's got to have x plus 3 in it, and it's got to have x plus 2. So x plus 3, x plus 2. For our first fraction here, the x plus 3s are going to cancel. That's going to leave us with 5 times x and 5 times 2. So 5 times x is 5x, 5 times 2 is 10. Then our equal sign is going to get brought down. Right after the equal sign, I notice I've got an x plus 2 in the numerator and x plus 2 in the denominator. Those are going to cancel each other out. I'm left with x times x and x times 3. Well, x times x is x squared. X times 3 is 3x. Moving to the last term on the right-hand side, I see I can cancel the x plus 3 with the x plus 3 on the top, the x plus 2 on the top with the x plus 2 in the denominator at the bottom there. So I can cancel out both of the terms in the least common denominator, and I'm just left with 2. It is a positive 2, so I'm going to write plus 2. Looking at this, I notice since I have x squared right here that I have a quadratic. Anytime we have a quadratic, we want to move everything to one side in order to factor. So I'm going to subtract 5x and I'm going to subtract 10. Again, we're always keeping things balanced. If I subtract 5x from one side, I've got to subtract 5x from the other. Same way with the minus 10 on both sides. So when I do that, that's going to give me this equation. When I look at this equation, the first thing that stands out to me, again, it's a quadratic, so I'm going to try to factor it using the asterisk method. So I'm looking for two numbers that multiply to give us -8, but add to give us -2. Those two factors are going to be -4 and +2. So there are my two factors. I'm going to take my two factors and set them equal to 0. So I have two solutions, x equals 4, x equals -2. But as always, when you get two solutions, you need to check to make sure that neither one of them is extraneous. So I'm going to go back to the original and I'm going to check the denominators to see if I plug in 4, if I will get 0 in the denominator. So looking here, I'm just going to look at the first two because those two factors repeat in the third term. If I plug in 4, I would have 4 plus 3, which is 7. That's going to work. 4 plus 2 is going to be 6. That's also going to work. So 4 is definitely a solution here for us. But we're not done. We need to check -2. When I check -2, if I could write, -2 plus 3 is 1. That's perfect. You're allowed to divide by 1. However, when I plug in -2 into this fraction or this denominator, -2 plus 2 is 0. That is most definitely not allowed. So we're not allowed to divide by 0, which means x equals -2 is extraneous. So x equals -2 is not a solution. Doesn't mean we did anything wrong in the problem. It just means that's an extra answer that doesn't work in this sense. Go into the backside. Questions 6 and 7 are our complex number problems. We are going to multiply all of these by the conjugate. So if you remember the conjugate, we talked about multiplying by the opposite side of the middle. So we're going to multiply both of these by the conjugate, which is going to be -3 plus 2i. So we're going to multiply the numerator and the denominator by the conjugate, which is -3 plus 2i. This is going to create 2 box problems for us. So we're going to make a box problem from the numerator and a box problem from the denominator. So there's our numerator. For the denominator, we're going to have another box. Then we're going to just fill in our boxes. So for the numerator, -3 times 4 is -12. -3 times 7i is -21i. 4 times 2i is 8i. Be careful with this bottom box. 7i times 2i is 14i squared. We talked about this week, we replace I squared with -1, and -1 times 14 is -14. I'm going to go ahead and combine like terms here. I'm going to have my real parts first. These two are real, -14 and -12 combined to give us -26. I'm going to combine my imaginary pieces as well. -21i and 8i combined to give you -13i. We're going to repeat this process for the denominator. So looking at the denominator, we're going to multiply -3 times -3, which is +9. -3 times -2i, which is 6i. -3 times +2i, which is -6i. -2i times +2i is -4i squared. I squared gets taken out and replaced with -1. -1 times -4 is +4. So now when I look at this and I go to combine like terms, I'm going to have 9 plus 4, which is 13. And then my -6i and my +6i are going to cancel. So my denominator for this case needs to be 13. Remember, we're going to write it 2 times and create 2 fractions here. And then we need to reduce each fraction individually. So -26 divided by 13, well, that just simplifies to 2. -13i divided by 13 reduces to -1i, or just -i. So that's how I would write my answer. You could put a 1 in front of that I and it would still be correct. It's just not customary because it's not required. Last one over here on the right-hand side, very similar to the last question. We are again going to multiply by the conjugate and create two box problems. So my conjugate's going to be -8 plus 6i. Remember, you're only allowed to change the sign right here in the middle. You're never allowed to change that -8 that's out front. And again, I'm going to draw myself two boxes, one for the numerator, one for the denominator. So I'm going to fill out my boxes here. Looking at the first box, 6 times -8, -48. 9i times -8 is -72i. 6 times 6i is 36i. 9i times 6i is 54i squared. I squared gets taken out and replaced with -1. -1 times 54 is -54. So now I'm going to combine my like terms on this one, just like we did the last one. I'm going to take -48 and combine it with the -54 here. When I combine those, I'm going to get -102. When I combine the imaginary numbers here, the -72i with the +36i, that's going to give me -36i. Then we're going to repeat our process over here on the right-hand side with the denominator. -8 times -8, +64. -6i times -8 is +48i. -8 times +6i is -48i. And -6i times +6i is -36i squared. I squared gets taken out and replaced with -1. -1 times -36 is +36. When I go to combine like terms for our denominator box here, we're going to have 36 and 64 get combined together to give you 100. The -48i and then +48i are going to cancel. So all we're left with for the denominator, is 100. So both terms from the numerator are going to get divided by 100. So now when I look at these, I need to reduce the -102 divided by 100. I can divide both numerator and denominator by 2. So that's going to give me -51 over 50. Then I'm going to take -36 divided by 100. I'm going to divide numerator and denominator in this one by 4. 36 divided by 4 is 9. 100 divided by 4 is 25. Don't forget your I. So this right here is our final answer written as a complex number. So the real part always comes first. The last part will always have the imaginary number in it.